Hello class, welcome to our lesson. We're going to start chapter 5 today, which goes back to some statistical measures, and today we're going to look at random variables. What you'll notice starting today with the rest of the statistics chapters is everything's going to kind of build on itself from here. So we're going to go ahead and get started on section 5.2 today and explain a little bit about random variables. Random variables are typically denoted by the letter X and represent a single value that's determined by chance for an outcome of a procedure. Okay, for example, if I toss a coin 5 times, X could be the number of tosses that are tails. The distribution that occurs is what's known as a probability distribution. Now this will look kind of like a table like a frequency distribution a little bit, but it'll be probability based. And we're going to look at it mainly in a table format in order to be successful on some of these questions in this chapter. Okay, so here's an example of an unfair coin. So it says that there's a 70% 0.70 probability of getting a tails. The coin is tossed 5 times and X represents the number of tails. So what happens here is I could have got 0 anywhere up to 5 tosses that are tails. Now these probabilities are given to you right now. We're going to go through how to find some of those things later on as we go through the lessons. But for now they should be given to you just so we can see what they are. Now let's think about it. It makes sense if the probability of getting tails is 0.7 for each one, or 70%. The probability I toss a coin 5 times and get all tails would be pretty small, or I'm sorry, 0 tails is pretty small, and it kind of increases, and then 3 and 4 have a lot, and then 5 drops back down because getting all 5 would also be a little bit more unlikely. So it makes sense mathematically that this kind of has this type of a curve to it if you go from lowest to highest and back down. It's not exactly bell-shaped because it's kind of skewed over to the left a little bit because there's smaller numbers to the left if we're thinking about it from the idea of a histogram. But X represents how many of those 5 tosses are tails. Here's important things about the table on the last slide that should be known. First off, all the probabilities should add up to 1. Now it's possible it's 0.999 or 1.01. It could be a little, just a thousandth off because of rounding errors once we write them. All of the probabilities in the table should also be between 0 and 1. Now, sometimes when we have small probabilities, which you'll see this in some tables that we're going to look at later on in this chapter and in the semester, you'll see some numbers will say 0 plus. Well, most of these answers are just rounded to 3 decimal places on these tables, and if it's something really small like this 0.00, it has 5 zeros then the number, it's probably denoted by 0 plus, which means it's really unlikely. It's not 0, but it's very unlikely to occur at that point. We're also looking at things that are dealing with discrete and continuous variables. All the probability distributions are going to be discrete because think about the number of tosses that are tails. It's either 0, 1, 2, 3, etc. tosses that are tails that you would be looking at in that situation. Compare that with continuous. Continuous variables, things like an amount or a volume or weight, those things are much more difficult to have this table idea because they're on a continuous scale. So we're going to be looking at mainly discrete variables because they have these countable ideas of 0, 1, 2, 3 when we first get started with probability. Okay, this next one is creating our own table. So this is Px, the probability of x is x over 10, where x can be 0 through 4, excuse me. So if I plug in 0, I get 0 out of 10, plug in 1, 1 out of 10, 2 out of 10, 3 out of 10, etc., 4 out of 10. Determine whether this works for probability distribution. Well, this is going to work because if I add up all the probabilities that I just found, they add to 1. Also, the lowest probability is 0, which is okay, and the highest probability is 0.4, which is all those probabilities are between 0 and 1, including those numbers. Graphing this information should look just like a stair step. So they'll probably get 0, 0, and then 0.1, 0.2, 0.3, 0.4. You don't typically see this histogram as often as you'll just see this table, so I would focus more so on the table than I would the histogram as you're looking through these questions. The next thing we're going to look at is how to find the mean, standard deviation, and variance based upon a probability distribution table. When looking at these questions, the one that you want to be most comfortable with is how to find the mean of the table. So this mu equals sigma of x times p of x, and we'll go through an example. It's the probability. It's take the x value times its probability, so it's like the first column times the second column. Find all those answers, and then add them back up. You're going to have to be able to find that one by hand if needed. Variance and standard deviation will either be given to you or they'll be in a table format where you can use StatCrunch in order to find it for something like your homework. Okay, remember sigma, okay, is the standard deviation and sigma squared is the variation, or excuse me, the variance. When finding these answers, you want to round to one spot, typically further than whatever the random variable is, unless it tells you otherwise. Sometimes when you're looking at certain situations, it's better to have more numbers, but that's a general rule of thumb that you could use to help answer questions. I'll typically tell you, hey, round to 3 places, for example, as you find those answers. Just some things that you want to look at to be successful. Okay, so let's go back to the unfair coin. This is the same table we started with, but now it says to find the mean. Okay, so to find the mean, what I'm going to do is I'm going to take x times p of x. So 0 times 0.002, 1 times 0.028, 2 times 0.123, or 132, and I do all of those six pieces. I just multiply across, and then I add them all together. Here's some things you want to make sure of. First off, your number better be between 0 and 5, because your mean should be between these numbers somewhere. In this case, we get a mean of 3.499, or just about 3.5. What this says is we should expect, if I toss the coin 5 times, on average I should end up with 3.5 tosses that are tails, which kind of makes sense because 3.5 would be just 70% of that 5, which should be between these two. Now this one works out really nicely because it's a perfectly balanced probability that comes from formulas that we'll learn later. In other situations, it might be a little bit more challenging to think about that number, so this strategy will work on any probability distribution. And then what this says is if I toss the coin 5 times, I should expect to get 3.5 tails out of the 5. In StatCrunch, when you're doing your homework, you can also find this information. In StatCrunch, you should be able to find the mean and the standard deviation, and don't forget the variance is the standard deviation squared. You'll just type in or have the data typed in, or just click and copy and paste it into StatCrunch, and then go to Stat Calculator Custom, and you should be able to find what you need when it comes to those situations. But Stat Calculator Custom, and then you'll have to kind of pick L1 and then by L2. That's going to be the route you need to take. If anything, I would test this one out. Okay, this one should have a mean of about 3.5 and a standard deviation of 1.02. Open up StatCrunch and see if you can test that out to see what you can get for that answer. And I think that would be a good suggestion to make sure you understand how to find that as you move forward using StatCrunch. Okay, so basic ideas today. X is the number of successes, like for the tossing of the coin. Remember, you have to be able to find the mean by hand. Standard deviation and variance should be found using technology in some way. Don't forget standard deviation squared is the variance. And we're going to continue to build off of this. So you want to make sure that you understand these topics fairly well so that when we move to the next step and then the next versions, that you're going to be comfortable with it as we move forward. Have a good day, everyone.